Greetings, judges. I am the representative from the team of Ying in the HKUST Institute for the Environment's Clean Air Challenge. The name of our project is the Autonomous Pedestrians Air Purification System. And this system consists of two major parts, the power generation system and the purification unit. First of all, we'll be attaching the purification kit onto a traffic light. And the reason that the word autonomous is included in the project is because the system operates when the traffic light for a pedestrian is turned off. That means when it's red, the device will operate and suck in all the polluted air. And when the pedestrian light turns green, it will deactivate and recharge. The charging system consists of a pressure plate that is connected to two gears. The two gears will drive a generator to produce electricity that can be stored in the battery unit of the purification kit. And that means when a pedestrian steps on this pressure plate, electricity can be generated, and therefore this system is self-sufficient in terms of electricity. Then we'll be talking about the general layout of the entire system. As you can see, the yellow part is our pressure plate, and the purification kit will be placed directly next to the traffic light and connected. Now let's talk about the purification kit itself. The purification kit consists of three parts. Inside it, we can first see the fan. The fan is responsible for driving polluted air into the purification kit. And then we have the ultraviolet light bulbs. These bulbs will disintegrate some of the molecules of the suspended particulates, and there is also an electrostatic precipitator connected into the purifier. The wall of the purifier is magnetic, and hence it can attract the suspended particulates to stick onto the wall. The walls are coated with the element rhodium, which catalyzes reaction for breaking down suspended particulates. For example, 2 carbon monoxide plus 2 nitrogen monoxide under the catalytic reaction of rhodium will produce 2 carbon dioxide and 1 nitrogen gas molecule, with the previous 2 molecules being toxic and cancerous to the human body, and the later 2 being completely harmless to the human body. As we can see, with these 3 measures, we can greatly reduce the amount of suspended particulate near the air which pedestrians will walk by. Now let's discuss some of the design principles of our system. First of all, when we were discussing about the suitable catalyst for our system, we had came across 2 candidates, first being the platinum element and the second being the rhodium element. And both of these are suitable for the catalytic reaction for suspended particulates. However, based on our research, although rhodium is marginally more expensive than platinum, it is 7 times more effective when catalyzing the reaction of nitrous oxide and related chemicals. Therefore, rhodium is selected as the final candidate for our coal tank. Secondly, we got our inspiration of our power supply from the game Minecraft. In Minecraft, we can see that there are a lot of ways to generate power, although not all are authentic. The concept of pressure plate is one worth adapting, as it channels the change in potential energy and converts it into other forms of useful energy like electrical energy. Thousands of people walk on the street every day, and even more crosses the pedestrian roads every day. If we turn that kind of energy into electrical energy, we can actually save a lot of our resources and our fossil fuels, and we can even reduce more emissions of suspended particulates, as when less electricity is needed, less production will be made and less fossil fuels will be burned. Finally, we adapted the system with one last modification, which is the electrostatic precipitator. While in our discussion, we thought that it would be good enough to just have a chemical converter and a physical disintegrator, the UV light, both of which are very effective at disintegrating the suspended particulates into non-harmful substances. But we thought that just using a fan would not maximize the amount of time where the polluted air will stay in the purifier. And after the discussion, we researched on some potential candidates, and at last we settled on the electrostatic precipitator, which can stick the suspended particulates onto our wall, which is coated with chemical catalyst. This will further the amount of time for the catalytic conversion to occur, and this will ensure that the air purified by this system will be of highest purity. Overall, we think that the system might have a very high production cost, but as stated, this is only a prototype, and there might be changes that we will be able to make in the future if we are to produce a more or practical version of this system. But overall, we still think that the system should be adapted widely in Hong Kong, as the suspended particulates in our urban area is extremely high, and the flow of people walking across the street in this urban area is also very high. We can maximize this flow of people into energy and use this energy to purify the air in our city. And this is our design principle for our autonomous pedestrians air purification system. This would be the end of our presentation, and thank you for listening. Goodbye.